3 kilometers below the rig floor, the pressure trying to push into your wellbore is enough to punch through solid steel. Every single well ever drilled has fought this battle. Most win. In 1979, one didn't, and it burned for almost a year. Underground, oil and gas sit trapped in rock, held there by pressure, sometimes enormous pressure. The only thing stopping that pressure from rushing up the wellbore is the weight of the drilling fluid sitting on top of it. Engineers call this hydrostatic pressure, literally, the weight of the mud column pressing down. As long as that mud pressure is higher than the formation pressure, everything stays put. But if the mud gets too light, or the formation is stronger than expected, fluid starts moving the wrong way, into the well instead of staying in the rock. That's called a kick. Here's the part most people don't know. A kick doesn't start as an explosion. It starts as a tiny imbalance, and rigs are built to catch it in seconds. Crews constantly compare how much mud goes down the well against how much comes back up. If more comes back than went in, something extra is entering the system, and that something is usually gas or fluid from the formation. There's also something called gel strength. When mud sits still, it thickens slightly, like a gel, so cuttings in any fluid that snuck in don't just fall or rise freely. That gel behavior is tested in real labs with viscometers, measuring exactly how much structure the fluid builds over time. The first response to a kick is almost always the same: increase the mud weight. Heavier mud means more hydrostatic pressure pushing back down, rebalancing the fight. But this has to be precise. Too light, and the kick keeps growing. Too heavy, and the mud pressure can crack the rock itself, causing a different problem entirely: lost circulation, where fluid disappears into the formation instead of staying in the well. Every well has a pressure window it has to stay inside. Too low is a kick, too high is a fracture. Engineers plan for this window before a single meter is drilled. If the kick isn't caught by mud weight alone, there's a mechanical failsafe sitting right on top of the wellhead, the blowout preventer, or BOP. It's a stack of massive valves. Some, called annular preventers, squeeze shut around the drill pipe like a fist closing around a hose. Others, ram preventers, are solid steel blocks that slam completely across the wellbore, sealing it no matter what's inside. This stack is the last physical barrier between controlled pressure and an uncontrolled blowout. It's tested, drilled, and rehearsed constantly, because when it's needed, there's no time for hesitation. None of this is improvised in the moment. The mud weight, the pressure window, the BOP, they're all planned before drilling even starts, based on how the rock below is expected to behave. A blowout isn't really a single failure. It's usually a chain: a kick that wasn't caught, a mud weight that wasn't heavy enough, a BOP that wasn't closed in time. Well control is the entire system built to make sure that chain never completes. Every well drilled is a negotiation with pressure that's been building for millions of years. Understanding that negotiation is what makes the difference between routine drilling and a blowout. If this helped you understand well control a bit better, subscribe for more. I'm MBM Srinivas, and this is Petroleum Enthusiast.